Question 4a. So we have an unlabeled bottle that contains straight chain halogenal alkane Q, and the molecular formula of this Q is C5H11X. X could be bromine, chlorine, iodine. A test is carried out to identify the halogen present in Q. Then the sample of Q is added to NaOH aqueous and warm. So this is hydrolysis, this part. After the hydrolysis, then nitric acid added. Many students wonder why nitric acid is going to be added in this part. Two main reasons. The acid is going to neutralize the hydroxide here, because later silver nitrate, the silver ion will form silver hydroxide. Okay, so this one has to be neutralized or removed. Another one is to react or to eliminate the carbonates that present in the solution, because the carbonate also will form precipitate with silver ion. Okay, this is why we use the nitric acid. After that, add a few drops of silver nitrate, then you see this cream precipitate. When you say cream precipitate, so we know that is the AgBr, silver bromide. Okay, so part 1, suggest the identity of X, so it's very clear now, it's bromine. Okay, part 2, write an ionic equations to describe the formation of the cream precipitate, include the state symbol, very easy. Silver ion aqueous plus bromide aqueous forms silver bromide solid. Okay, describe a further test which could confirm the identity of X. Okay, so you can use either this aqueous ammonia or concentrated ammonia. If aqueous ammonia form, then the precipitate means this one is partially dissolved. If use concentrated ammonia, so is dissolves. Okay, part B. The reactions of Q with the sodium hydroxide tends to proceed via SN2 mechanism. Okay, SN2 we know that is for the primary halogenal alkane. So what is primary halogenal alkane? Okay, when the C with Br, the carbon here bonded to one alkyl group, so is primary. So now we know that the structural formula of Q must be this one, CH3, CH2, 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 Br, because it has CH2, Br. Alright, it's a strict chain. Now explain why the reactions tend to proceed through this SN2 rather than SN1. So we know that SN1, it must undergo bond break first. So carbon partial positive, partial negative. Okay, if it's undergo SN1 means this CBr bond will break and it will form this carbocation. The carbocation form here is primary carbocation, not really stable. Therefore, it will not really form. So means this primary halogenal alkane, it will undergo another mechanism and form a more stable intermediate. Okay, so that's the reason why SN2 okay, we'll use for this halogenal alkane. Okay, so if it's undergo SN1, the primary carbocation produced is not stable. Why is not stable? Because it just has one alkyl groups only. One alkyl group exerting the positive inductive effect. Okay, so for part C, there are two different halogenal alkane, P and R. Both they have molecular formula C4H9Cl and separately dissolved in ethanol, heat under reflux with sodium hydroxide. From here we know that it must undergo elimination. Right? Okay. So the major product of each of these reaction is methylpropene. This one. Okay, first carbon, second carbon, methyl here. So last carbon. Okay, part 1. Name the type of reactions occurring. So it's elimination. Okay, write an equations for the molecular using the molecular formula to represent the reactions occurring. Very easy, this one. First, you need to know how the mechanism works. Let's use this one as example. the hydroxide will get the protons from adjacent carbon. So the carbon with Cl, this is the first carbon, second carbon is the adjacent carbon. So the OH here will get protons here to form H2O. Okay, CH bond break, these electrons move to the CC bond to form CC double bond, and the Cl bond here will break, and this one will form chlorides. Okay, so therefore it will form three products. Okay, this alkene, which is the methylpropene, with H2O with chloride. So that's why your equation you must give these three. Okay, part 3. Draw the skeleton formula for methylpropene. Very easy. This one, right? So first carbon, second carbon, okay, third carbon. There is one methyl here. Okay, give the names of P and R. In order to give this name, so you must know how they undergo elimination. Okay, this one, because methylpropene itself is a branch molecule, so the halogenal alkane that form this methylpropene most likely also need to be a branch molecule. Okay, so since this one is giving C4, if straight chain, okay, like this, branch is just this C with one H. Must be a branch molecule, means the molecules that form the methylpropene must be this and this. Okay, so let's say 2-chloro 2-methylpropane. Okay, this one is the first carbon, second carbon, okay, third carbon. So 2-chloro methyl 2-methylpropane. So we know that if this molecule undergo elimination, this will remove, this also will remove. Okay, then it will form this methylpropene. And the 1-chloro 2-methylpropane also will do the same thing. 1-chloro, first carbon, second carbon, third carbon. 1-chloro 2-methylpropane. So this hydrogen and this chlorine also will remove. So it will form this methylpropane. Therefore, answer must be these two. Okay, that's all for this question. Thank you.